Hi, I am Sam, your teacher, Sam, my teacher, Sammy, teacher. You learn at school that when you add the interior angles of any triangle, they always add up to 180 degrees, which is an important idea in all math courses, especially in geometry and trigonometry. So we take the idea for granted, but like I always emphasize, simply accepting the rule without even wondering why is not a good way of learning anything. So in this video, I'm going to show you several different ways to prove that the three angles of a triangle actually add up to 180 degrees. Now let us begin. The first way of proving the rule is simple but quite primitive. Here, I cut out a triangle and labeled each angle A, B, C. And I did the same thing for the other side, angle A and angle B right here, and angle C. Now, what you can do is simply tear off each corner. Told you it's primitive. And what I'm going to do is put angle A and put angle B and put angle C all together. Now you see that it forms straight angle, which is half of 360 degrees, so it is 180 degrees. Now, the second way of proving is going to sound more educated. I have another triangle, and I did the same thing on the opposite side. I labeled angle A, and same thing on the opposite side, and B, as you can see, and C. Now what I'm going to do is I'm going to measure this side. It's 10.8 centimeters. So half of that is 5.4 centimeter. I'm going to mark that right here, 5.4. And that's going to be the midpoint of side AB. Midpoint is the point right in the middle of the side, which cuts the side into two equal segments. Now I'm going to do the same thing for the other side of the triangle. It measures 13.4 centimeter. So half of that will be 6.7 centimeter. So I'm going to mark that. 6.7. And that's going to be the midpoint of side AC. Now I'm going to connect these two midpoints. And I'm going to fold the triangle along this line. And you have two isosceles triangles. Isosceles triangle means the legs of the triangle are congruent to each other. They should be congruent because you see this segment was equal to this, right? So I'm going to fold this part. And I'm going to fold this part as well. Okay, now what you have is a rectangle. And look at the bottom side of the rectangle. You can see that angle A and angle B and angle C, they again form straight angle, which is 180 degrees. So that was the second way of proving that the interior angle sum of any triangle is 180 degrees. Now, Before we move on to the next way of proving the angle sum, I need to give you some basic knowledge that you learned in geometry. Let's say you have two lines and you have another line that crosses both of them. By the way, this kind of line is called a transversal. Now, the angles at the same location, upper right corner and upper right corner, these angles are called corresponding angles. And if we have two lines and they're cut by a transversal, the angles at the opposite location, one lower left and the other upper right, these angles are called alternate angles. And when we have two lines intersect, the opposite angles at the intersection are called vertical angles, and they have the same degrees every time. So I want you to remember these names: corresponding angles and alternate angles and vertical angles. Now, if you have two lines that are parallel to each other, which means the lines run in the same direction but never intersect each other, and you have a transversal that crosses both of the parallel lines, then the corresponding angles, the angles at the same location, always have the same degrees. And since vertical angles have the same degrees all the time, then we can conclude that the alternate angles have the same measurement as well, since they all equal to each other in degrees. In other words, if angle 1 equal to angle 2 and angle 2 equals angle 3, by substitution, we can say that angle 1 equals angle 3. So again, when you have two parallel lines cut by a transversal, the corresponding angles are congruent and also the alternate angles are congruent. And now we are ready to prove the angle sum. Let's first draw a line that is parallel to this space. Then we know these angles are alternate angles and they have to be equal to each other because the lines are parallel. So that makes this angle B as well. And same thing, these are alternate angles and that makes this angle C. And these three angles, A plus B plus C, add up to 180 degrees because that's the straight angle, which is half of 360 degrees. So we can say A plus B plus C equals 180 degrees. So we know that the interior angles A, B, and C will also equal 180s. And finally, the last way of proving that the interior angles of a triangle add up to 180 degrees is similar to the previous one, but a little different too. First of all, I'm going to extend the base a little bit. And I'm going to draw a line that starts from this corner and also parallel to this side. And since they are parallel, we know that corresponding angles are congruent. So if this is B, this angle has to be B as well, because these angles are at the corresponding locations. And since the alternate angles are congruent when the lines are parallel, we know that this angle equals this angle. So this is A as well. And since the sum of A and B and C is 180 degrees, we can also say the sum of A, B, C also equals 180 degrees. So altogether I showed you 4 different ways, but their conclusions are the same. The interior angles of any triangle add up to 180 degrees all the time. Thank you for watching my contents, and I'll see you next time.